Okay, dear students, let us first learn how to find the H value and the S value of in different points on the TH diagram or HS diagram. So here I have drawn the TH diagram for the steam. So I am taking only one pressure line, and there are some specific points on this. So this line which connects the phase change points or is called the saturation line. So we can divide this into three portions. So the points on this up to this critical point are saturated liquid points or fluid points. So any point on this curve, that is the saturation curve, so it indicates the corresponding value in the H. So here, as it is in the fluid side, so this will be HF, and the heat is added, so the enthalpy is added, so the temperature also rises at one point. So if it is atmospheric pressure, so at 100 degrees centigrade, so the water will be getting boiled. So the steam formation starts here, and here at this point, where this is the points on the saturation, which is the gaseous state. So here the steam formation is completed. So all water, so here the water is there, so all water at 100 degrees centigrade, above 100 degrees centigrade, if you are heating, the heat is added and the steam is formed, and here the complete steam is formed. And if you are further heat the steam, it will become the super heated steam. So this region is called the superheated region. So any point on this line is gives HF value here. So we can divide it into two parts. So on the other side, this is the vapor state or the gaseous state. So here, because it is the saturated point, so we can get the Hg points. So all these points are gives the value for Hg, and here up to this critical point we are getting the HF value. So in between these two, the steam condition is wet. So here the wet steam is at any point on this pressure line we are getting the wet steam. So how to calculate this wet steam? So what is the relation between this? So at any pressure we will get the liquid point HF and the saturated steam point at Hg. These two values can be get from the steam table directly under the HF and Hg value. I will show one example. So this is the steam table, and see that. Okay, so let us take the, here it is given that it is in the saturated water and steam pressure tables. So here the pressure is given and the temperature, corresponding saturation temperature also is given, and here it is Vf. So this Vf is the specific volume at F point here. So all these points we are getting this Vf at any pressure. So the pressures are given here. So for any pressure we will get the Vf here. So these points will give the Vf. Directly we can get the corresponding pressure and corresponding Vf here. And this is Vg. So this Vg is taken from or related to these points, the gaseous point, that is the steam point. So for example, at 14 bar I am getting the specific volume of the steam at liquid this stage, that is the Vf is 0.00149 meter cube per kg is the value if this is the 14 point. 0 line, pressure line. And for this, the up to at this point we am getting VGS point 14073. So here this point is 140. This is, I am talking about only for the specific volume. Similarly for HF, so this point. So what is indicated here is this HF point. So HF corresponding to the 14 is 830.1. So this is that point. And here, so 2787.8. So this is HG. So HG is this point. So I am getting the HG, the steam enthalpy. Here it is the liquid enthalpy. The water enthalpy is here and the steam enthalpy is here. So in between this we are getting the HFG. So which means that the heat available here in this region. So Hg minus Hf is the HFG value here. So suppose if I am having a point here, I can directly read the value from the table. Or if I am getting a point on this line, for this point I can read the value here. Suppose if I am getting a point here, so which is in the wet region. So this H, for example, if I am taking the first point, so for that point it is in the wet region, so I will write this H wet. So for getting this point, so I must supply this much of heat. So this much of heat is nothing but, first I will split into two times. So up to this, I know what is the value, HF value. So the HF heat to be supplied, then plus this portion. So what is this portion? So totally it is HFG. So I am taking a percentage of HFG to arrive this point. So if I put directly HFG, I will get the HG value. So the percentage of HFG. So this is the value of H for this point. For any point in this region, so it's based on the dryness condition. So for any dryness condition, I should take the HF value first, and then the HFG, I should know what is the HFG, total HFG, and so based on the dryness fraction, I will take the amount of the heat added up to that point. So summing up these two, I am getting this point. And for the wet point, I am getting directly from the table Hg value. Okay, so now if the point is here, so maybe in the superheated region, so what will be the superheated region value? So if the H value is here, so at this point, so you have to calculate H superheated using, so up to this point we know what is the value of heat added, it is Hg. So I should put Hg. Then this increment will be the specific heat of steam, CPS, and the temperature. So what is the amount of temperature of superheated? So this temperature minus this temperature, that is the increase. So T saturation temperature at that particular point. So what is the superheated temperature I am getting at that point, and so what is the saturation temperature for that pressure? So that should be the difference in the temperature into specific heat is amount of heat added in this region. So up to this I am having Hg. So combining these two, I am getting the value of H for this point. So this is how we have to calculate this H value for different points. Similarly, if you see the HS diagram, so H values will be on this axis, Y axis, and the S value will be this one, and there are some different pressure lines. Suppose if the steam is expanded, so this is the saturation line. So above the saturation line, the steam will be in the superheated condition, and below in this region it is in wet condition. So along this path I am getting the saturation, dry saturation condition. For example, if I am having steam is here at this particular pressure. Okay, so let us take this is my point, and this is saturation. So this saturation pressure and particular temperature I can get the value from the steam tables. But if the steam is expanding, which means that the expansion will be taken as isentropic process. So for all these points, any point on this line, the corresponding S will be same. So if the steam is expanding from the saturation condition to this point, so at this pressure, so this steam is expanding from this pressure to this pressure, so the pressure drop is there, so the expansion will take place at constant. So this is first point, this is second point, so S1 is equal to S2. So similarly here this is in the wet condition, so S wet condition will be equal to S1, again this one, but this S wet will be can be taken as SF, that is this point, and then plus X into SFG. So this is the wet condition, so that will be equal to the initial entropy. So using this we can calculate any point here, the entropy of any point in the wet region. So what will be the entropy for a point in this condition? For example, if I am taking a point on this superheated condition, so what will be the entropy for that point? So here we are using the value, so S superheated region will be got from the, so SG plus the specific heat of steam, then ln of T superheated temperature divided by Ts. So both should be in Kelvin. So if you put all this thing, we will get the superheated value of S. So entropy S will be calculated using this formula. So I think you can find the relations in this thing. So for anything in the wet region, we have to get the X value first, then we have to calculate the either H or S. Using this relation, we will come to the we can calculate the data using the steam tables. Okay, so we'll continue or see the details in the next slide. Okay, thank you.